All right, let's look at some math. We'll cover the parallel lines cut by a transversal section of Math 8, Term 4. Let's jump right into it. All right, so what's a transversal? Okay, well, essentially, if we take something, in this case, two parallel lines, and we cut them by another line, that's what a transversal is. Okay, basically it's a line cutting other lines together, and in this case, we're focusing on these two being parallel lines, all right? And we use those little markers to say they're parallel. So, when we talk about parallel lines, we have some theorems and we have some rules that talk about different positions of things, okay? And really what it comes down to is we are going to connect angles that are equal and also angles that added together equal 180, okay? And it kind of has to do with the fact that we're dealing with the same angles, okay? Because these are straight lines, okay? They're not curved lines, they're straight lines. And because we're looking at similar angles, okay, there's a lot of information we can say about these things, okay? And the first type is what we call corresponding angles, okay? These corresponding angles. Corresponding angles are, the best way to think about it, is I were to make a box around these two intersection points, whether it's here, here, over here, or on my original one, they fit in the same position of that box. Okay, so the blue angle corresponds with the blue angle, green with green, purple with purple, and red with red. Okay, so with corresponding angles, they're always going to be equal to each other. Because of the nature of how these angles meet, because parallel lines have the same slope, because that line has the same slope with itself, you end up creating those same angle measures here and here, or in the other three positions, okay? Those we call corresponding angles because they are in the same position and because they are equal, okay? So that's one thing, okay? Let me do some erasing and I'll have to redraw some stuff. Okay, so that's one type, is the corresponding angles. Okay, I guess it should also be mentioned as well that, remember, a linear pair is two angles that make up a straight line, two or more, I should say. So we actually end up with a lot of linear pairs here. Okay, basically any two angles next to each other are going to form a linear pair. Okay, so like 2 and 1, 1 and 4, 4 and 3, 3 and 2, and so on. Okay, right? You get the picture. So we have that situation going on. We also have vertical angles. Vertical angles, remember, if you have an X, they're angles opposite each other. So here and here, here and here, here and here, here and here. So like 2 and 4, 1 and 3, 5 and 7, 6 and 8. Those are vertical angles, which they're not part of the definitions here, but they are also, the situation is also happening. So that's something to think about as well, okay? And so really when it comes down to it, when we're dealing with parallel lines, you're only going to have two different angles, okay? That's really all you're going to end up with, is two different angles, like 1, 3, 5, and 7 are going to be the same angle measure. Maybe it would be 110. And then 2, 4, 6, and 8 are also going to be the same. Maybe it's going to be 70. Okay, you will end up seeing when you deal with this, that's the situation you always run into. Okay, now we also have what are called supplementary angles. That's kind of the supplementary, they add up to 180. So that's all this stuff here are going to be supplementary. Okay. Now, we have alternate interior angles, okay? Also, alternate interior angles, okay? Here's kind of the breakdown of the words. Alternate means they're on opposite sides of this transversal. Interior means they're in between the parallel lines. Okay, so alternate interior angles would be like angle D with angle J, or 3 and 5, or this angle with this angle. Okay, they're going to actually end up being equal. Okay, again, they're one of these that is equal. Okay, and we did already talk about the vertical pairs that are equal, so I'll just add that one in. Okay, but also this angle and this angle are going to be alternate interior, so 4 and 6, or F and G. Okay, because they're, again, inside the parallel lines, and they're on opposite sides of the transversal. Okay, now just like we have alternate interior angles, we also have alternate exterior angles. Okay, the alternate still stands for the same idea, that they're on opposite sides of the transversal, but the exterior means they're on the outside of the parallel lines. Okay, so this is like the interior, then out here and here is the exterior. So B and L, or 2 and 8, or this angle with this angle. Those are alternate exterior. Okay, same with C and K, or 1 and 7, or this with this. Okay, so those ones are equal as well. Okay, and those are all our angles that are equal to each other. Okay, those are the alternate exterior. So my suggestion when you're working on this stuff, look up these to remind yourself. Do an image search on Google and just, talk about parallel lines cut by a transversal, because sometimes it's hard to have these all memorized. Okay, that can be tricky. All right, so that was alternate exterior angles. Okay, now the supplementary angles, one that they don't have written here, we call consecutive interior angles. And I think they're calling it this one. Oh, nope, that's this one. Okay, so what that means, consecutive, means they're not across the transversal, so they're on the same side of the transversal, and they're interior, so they're in between. They're in this interior zone. So F and J would be consecutive interior angles. D and G would be consecutive interior. This angle and this angle would be consecutive interior. 3 and 6, 4 and 5, those two and those two. Okay, and with those, they add up to equal 180 degrees, right? Angle 4 and angle 5. And the reason for that is because we know that angle 1 and 5 are corresponding, so they're going to be the same angle. We also know that 1 and 4 make a linear pair, so they are going to be, that's what the adjacent supplementary angles, that's a linear pair, right? Because a straight line is 180 degrees, so if I cut it in half, those two have to add up to be 180. That's like 1 and 4. So because 1 and 5 are the same, and 1 and 4 are adding up to 180, well, if I transfer out 1 and 5, because they're the same, 4 and 5 have to also add up to equal 180, okay? So that's kind of the idea there, okay? Now, the last thing, each pair of exterior angles on the same side of the transversal are supplementary. So that would be like number 2 and number 7. Because 7 and 3 are the same, 2 and 6 are the same, 3 and 6 add up to equal 180, which means, angle 3 plus angle 6 is the same as saying because 2 and 6 are the same, it's like angle 2. Because 3 and 7 are the same, I can substitute, and they have to add up to equal 180 just like the other ones, okay? So those are kind of all the different connections we have. So let's kind of jump into some questions and see how we use those. All right, Carmen is an engineer making plans to run a rail line represented by the transversal T through a city. Examine Carmen's rail plans to identify the measures of angle 1. The streets represented by lines V and W are parallel. Okay, so we've got the parallel rules happening here. What is the measure of angle 1? Okay, well, angle 1 is right here. It's a corresponding piece. See how if I drew a box, 1 and 155 are the same position, just like 2 and this one are, or 3 and this one are, or 4 and this one are. So it's got to be 155. Okay, which means, because 180 minus 155 is going to give us 25, right? So that would tell us if this is 155, I know that 3, because our vertical angles would be 155, which I know this would be 155, which means a linear pair here, 2 is going to be 25 degrees. So these are all 25, 25, and 25 degrees. All right, Carmen is planning rail lines for a new train station still. Help her find angle 1. Explain how you found that solution. So angle 1 is going to be the same as angle 2. It's also going to be the same as this angle. 2 and 17, that's a 180 degree angle, right? Added together, they're going to have to make up 180. So angle 2, measure of angle 2 plus 17 degrees has to equal 180. So if we subtract by 17, that would put us at 163 degrees. That's the measure of angle 2, which is also the measure of angle 1, so 163 degrees. Okay. All right, Carmen found measure of angle 1 this way. Measure of angle 1 equals 105 because if two lines are parallel, alternate exterior angles are equal. Is her answer correct? No, it is not. 1 and 105 would be those consecutive exterior angles. So they would be equal to 180. Measure of angle 1 plus 105 would equal 180. Okay, so angle 1 would be congruent with this angle right here, also with 3 because those are alternate exterior. And these two also make a linear pair. So just like measure of angle 1, measure of angle 3 plus 105 equals 180. So basically if I subtract by 105, which would give us 75, that's going to be angle 3 and angle 1 would be 75 degrees. Okay. All right, consider transversal T cutting lines P and Q. Which statement allows Carmen to conclude that line P and line Q are parallel? So now we're kind of working backwards, okay? Because just like we said, if they're parallel lines, these rules apply. If these rules apply, then we know the lines are parallel. So if I look at angle 2 and angle 6, okay, they are corresponding angles, which means they have to be equal. So if they are equal, then that's going to work. What about angle 1 and 4? Angle 1 and 4 are vertical angles, which would help us, but that's only for line P. That's not helping us understand anything about Q. That's why that one is not correct. Okay. Let's look at the next one. Measure of angle 1 and 2 equal 180. Again, that is true. They're a linear pair, but it's not helping connect our lines. That's why that one wasn't. Same with 5 and 6. That's why that one wasn't. Same idea. It's got to be the only one that connects the two lines is 2 and 6. Carmen is designing an intersection of the rail line and 4 streets. She wants to know which streets are parallel. She must be like the master at designing intersections with rail lines and streets, so that's why they always call her. So which streets are parallel? Check all that apply. All right, so let's see what connections we have. So 114 here, corresponding angle would be right here, and here, and here. So those should all be 114. Okay, which means if those don't add up to be 180, or those, and notice right there that that's not going to be the same, okay? So there's not, so that's telling me that this one is 112 and not 114. So I know C and E are not going to be parallel, okay? Because they would have to be 114. Okay, so 114 and 68, what does that equal? That would be 2, 8, that's 182. So that one's not going to work either. in terms of C and D. So C and D are not parallel. Okay, what about F? 114 and 66, that would be 0, 1, 8, 1. Okay, C and F are going to be parallel. So that's one parallel line. What about D and E? Okay, well, let's take a look at that one. So that would be 112. So for D and E to work, those would be consecutive interior angles. If they add up to 180 degrees, then they would also be parallel. 0, 1, 8, 1, that works out. So yeah, D and E would also be parallel. What about D and F? Well, those should be corresponding pieces, but they're different, so not going to work. And finally, what about E and F? Well, 112, we know that 114 and 66 add up to 180, and those are alternate interior angles between those two parallel lines. They definitely aren't the same, so those aren't going to work. So it's just these sets that would be parallel. All right, consider Carmen's new set of plans. Examine the lines that are cut by transversals to determine the measure of angle 1. What is the measure of angle 1 and why? All right, so now we got some weird stuff going on here. Okay, but notice our parallel lines are this line and this line, okay? We've got two different transversals. This is transversal M, this is transversal T. The transversals cannot be connected with anything, okay? They can't be connected. However, using transversal T, I know that this piece is going to be 7x minus 4 because they're corresponding pieces. Okay. I also know based on these two lines that I've got a vertical angle here, that this and this are going to be the same. Okay. I could have also said alternate exterior angles mean those two have to be the same, which means I can set them equal to each other, which also means I can then solve for x by simplifying 7 minus 6 is 1, both sides. So 9 equals x, which now that I know what x is, I can then figure out what this angle measure is, okay? So if I plug 9 back in to that, 6 times 9 is 54, plus 5 gives us 59 degrees. Okay, so I know that this angle right here is 59 degrees. I also see that we've got not a linear pair, but three angles that make up a straight line. So I know that the 59 degrees plus measure of angle 2 plus measure of angle 1 has to equal 180 degrees. Okay, so what else can we figure out? Now, looking at this transversal, okay, it does appear to me that honestly I didn't need to do any of that other work because 48 and angle 1 are in the same position. They're corresponding angles. So this is going to be 48 degrees. Okay, why? Because of the corresponding in transversal M, line M. Okay, which I could figure out what measure of angle 2 is based off of this. Okay, which I don't know, maybe they'll use that same diagram later. But basically I would add those two up and subtract them from 180. So 180 minus 107 would give us 73, right? Yeah, so measure of angle 2, that would be 73 degrees. Just if you wanted to know. All right, two parallel lines are cut by a transversal and form a pair of alternate exterior angles, okay? Parallel lines cut by a transversal. One angle measures 6x plus 5, and they're alternate exterior, so this would be 7x minus 4. So what can explain how to determine what those angles actually measure? So this is kind of what we did. We just did this, right, with these same numbers. Those we set equal to each other, and then we solve for x. And then once we solve for x, and I'm solving it slightly different now just for funsies, right, we get 9 equals x, which 9 in for x, that gave us 54 plus 5 gave us 59. Do it with 7. that would be 63 minus 4 would also give us 59, because they have to be the same thing, duh. So yeah, they would be 59 degrees. All right, we're back to these plans, and we solved them already, so go back to my other question. Well, we got x equals 9. Let's move on. Examine Carmen's plan. What is the measure of angle 2? Wow, we already found the measure of angle 2 as well, didn't we? So go back and see how we found the measure of angle 2. That was 73 degrees, right? We found 1 was 48 degrees. We set these two equal and found that x was 9, which then told us that this was 59 degrees. Then we went 59 plus 48 plus measure of angle 2 equals 180. Found that that was 107 plus measure of angle 2 equals 180 divided by 107, or not divided, wow, minus by 107, and the measure of angle 2 was 73. Okay, but if you want to see me figure that out on the other one, you can look at that. All right, parallel lines S and T are cut by transversal R. Which angles are alternate interior angles? Interior means in between. Alternate means across the transversal. So that would be 3 and 5. And then also 4 and 6. And those are the only ones that would be it. So the rest aren't. Parallel lines S and T are cut by transversal. R as shown below. What is the measure of angle 1? Okay, so I can figure out what this is based on the fact that these are alternate exterior angles, so I can set them equal to each other, right? If by setting them equal to each other, I'm able to, they really like 6x and 7x. I can figure out what the value of x is, okay? Once I know what the value of x is, I can plug it in for that, which 7 times 20 is 140, minus 2 would give us 138. Then I know that these two form a linear pair, so I know that if I go 180 minus 138, that's going to tell me what my angle 1 is. So we borrow, we get 42 degrees. So it's 42 degrees. All right, which correctly describes how to determine the measure of angle 1. So it's not in the same position. It's not corresponding, but it is connected to 1 and 2 are a linear pair, and 105 and 2 are the same. So the 105 angle and angle 2 are alternate exterior angles. Check. So angle 2 must measure 105. Angle 1 and 2 are supplementary. So if we go 180 minus 105, we get 75. That is correct. 1 and 5 are not corresponding. 1 and 5 are alternate exterior, but that means angle 2 measures the same, so that's why that one's wrong. And 1, yeah, those are all wrong. So it was the first one. Didn't even have to look at the rest. All right, which lists all the lines that are parallel to line S. Okay, so you kind of want to think about these separately. Okay, so 89 here between T would be congruent with this one here or this one here, not with that one there. So that one's definitely not going to work. So that one's out. Okay. Corresponding 89, this would also be 89. Does 89 and 91 add up to be 180? I believe it does. It does. So U, S would be parallel to U. And V, those would be in corresponding positions, so S would also be parallel to V. So only line U and line V. All right. If X equals 10, which lines are parallel? Check all that apply. So first we got to see what they all are. Now, if I look at this, it looks like we just are comparing everything, aren't we? So 8 times 10 would be 80. 80 minus 25 would give us 55. So that one is 55 degrees, which means 180 minus 55 would give us 125. So that would be 125. So that would be 125. So that would be 55. So this is kind of another way where you can just find out what all those angles are going to be, and we can use that to help us then compare things. 12 times 10 is 120, minus 5 is 115. So if that's 115, then that means that this would also be 115, which means 180 minus 115 would give us 65. So that'd be 65, and that would be 65. So if I look at D and E, they're definitely not parallel, are they? Okay. Because none of the corresponding pieces or alternate exterior, interior, supplementary, none of those work. Okay, what about C? So 10 times 10 plus 15, 100 plus 15, give us 115. So that's 115, which means that's 65, 115, and 65. So corresponding alternate interior angles, alternate exterior. Yeah, so C and D, definitely parallel. C and E, definitely not parallel. Okay. So now let's do B. 7 times 10 minus 5. 70 minus 5 would give us 65. So that's 65, which would also mean that's 115, 115, and 65, which means B, C, and D would all be congruent. So B and C are congruent, B and D, not B and E. All right, so I hope that helped, and that you can get back to work making progress on your Edgenuity, and let me know if you need any more help, please.